Hey, I'm Alan Furstenberg,
Hi, this is Roya.
and welcome back to Two Voice Devs.
Two-way steps.
Ryan, it's fantastic to have you on again. I feel like you and I haven't really chatted since I/O of last year, have we?
Absolutely. And Oyer is around the corner, so excited to be back.
I can't wait. There's so much coming up. Um, but we're not going to be talking about Google today. I put out a request a couple of weeks back saying there's this company called DeepSeek. I haven't had much of a chance to play with their models. Who has? And you spoke up and said, you've been playing with it a little. You found some interesting stuff. So I wanted us to talk about, I guess, DeepSeek in general and these models in particular.
Absolutely. I would love that. I usually talk about Guyel, and I think it's a quite interesting turn to talk about something else. And particularly, this model is, they had a few innovations that was really interesting to me. So I really welcome the opportunity to speak about what they have done.
Great. So we'll get into some of that. I guess what I know about it so far and kind of what took got a lot of attention initially was DeepSeek's a Chinese company, if I have this correctly. And they're claiming that they have trained these models on older generation NVIDIA GPUs. So they've gotten some really good results with their models using slightly older technology, but some very good techniques, which they've talked about. And I think that's what got a lot of people kind of woke up and said, these are interesting results. Let's see how good they are. So did I kind of capture the basics of them correctly for
Absolutely.
starters? Okay. So I know they've released two models right now. Can you tell it? I don't remember their names, unfortunately. What are these two models?
So they released a base model. I think it's called V3. And that's a model that they purely train without a lot of fine tune and essentially supervised fine tuning. And then they put another model on top of it called R1. That is the model that goes essentially with equal or almost the same performance as some of the major players right now in the field. And that model use a lot of reinforcement learning and also supervised fine tuning.
Okay. And so I guess, can you talk about what those techniques are?
I would love that. You guys be like, okay, let me walk you through what is happening and where we are and why this is very interesting. And I
Okay.
cannot start it without first talking about attention, because even we as human, we need that attention. So the idea of attention in general is, rather than looking at each token or word individually, we as human, we make sense of each word based on the word around it. Correct. So if I talk about apple and I don't mention what apple I'm talking about, there is an ambiguity of whether it's essentially fruit or it's a company. But if I talk about an apple phone or apple and oranges, we are sure that one is the technology and the other one essentially is the fruit. Building this mathematical calculation to put together the attention, it's a very expensive architecture. And that's the whole attention mechanism. And essentially the key query value matrices that we require to make sense of each word based on the word around it. So the first thing that DeepSeek made that, in my opinion, as a scientist, is very impressive. And honestly, it was not a new technique, but they just utilize it into this larger architecture, is this idea of bringing these matrices into a latent space.
Can you explain that a little bit? Because I barely understand attention in the first place. So kind of what does that mean by uh, bringing the matrices into this space?
Sure. Okay. Let me roll back a little bit. I know I take a tangent and I go like very far with it, but let me make it clear. Imagine we have one word, right? And this word has so many nuances to talk about it. And between you and me, we make if in small, essentially smaller word, like an abbreviation, that means the same word,
Okay.
right? Okay. That's the same idea as the latent space. So in the regular space, um, we define a word with a very large numeric representation in form of a vector or a matrix or a
Okay.
tensor, right? But we decide, we map it to a smaller vector that represent the same large vector, and that the smaller vector belongs to a smaller space called the latent space. It's like a juice maker. So you have the fruit and you also have the juice of it in a different space. Does it make sense
Okay.
now?
Yeah.
Okay, perfect. Okay. One more thing about before I can exactly say what is this new innovation about DeepSeek. So the way that this attention mechanism works is, imagine I love going to a nail salon and like pampering myself, so I explain it in that way. Imagine you go for a spa day, right? And there are different people that making sure that you look beautiful. So they do your eyelashes and they would do your nail, and each of them pays attention to a specific like beautifying process.
Okay.
That's the same idea almost as multi-head attention. So instead of having a one pipeline of paying attention to something, you have multiple of those, each of them paying attention to a specific. So one
So
of
when we say a specific thing, do we mean a particular um element of the vector? So
almost. So for example, one of them pays whether this word is an adjective or not. One of them pays
okay.
attention to the punctuation. One of them pays attention to the connection. So each of them essentially beautifies or pays attention to a specific piece, but they are not working single-handedly. The combination of their work is what brings on the value.
Okay.
Okay, so up to this point, we have the sentences, and we want to see what is the connection between each word to the word around them. But instead of just doing it once, we are doing it multiple times
Okay.
concurrently, and each of them pays a different aspect of attention, right?
So so it sounds like what we're getting in this case is for our token, our word, we're getting each, different do these have a name? Each
They
different
call it
element that
head, so we
okay,
call it
so
multi-head attention.
so each head will give it a weight saying, looking at, this word compared to the next word, there's not a strong correlation between verb and adverb. These are not verb adverb pairs. Or we've got another one that's saying, we have this word followed by a period, and we do tend to see that there's a strong correlation between this word ending a sentence, for example. And we've got multiple ones that are evaluating it and giving it a different weight for each one of those things to kind of sort of capture it correctly. Okay,
That's
wow.
yeah.
Okay.
That's the way that I explain it to myself. So now each of those numeric representation, they are very large, right? So they are really, really heavy to put them into a memory. Because to make this process efficient, you have to keep this numeric representation already in the memory. Now let's go back to the juicer idea. Instead of
Okay.
having this gigantic numeric representation in the memory, we condense them to smaller vectors that belong to a smaller space called the latent space. And
So
what
so
DeepSeek?
so
Go
this
ahead.
is like saying, I've got a bunch of different heads that give me a vector the size of, 2000 elements. I've got 2000 elements in this vector for this one representation. And instead of 2000 elements, I'm going to condense that down to 256, say.
Yes.
Okay, so this is trying to say we're taking this huge thing and trying to represent almost, but not quite, but almost the same amount, the same thing in a smaller space.
Exactly. Just to be clear, because these are concurrent, so we have multiple of those numeric representation. it's very invaluable and to make all of them condensed. You are making a huge amount
Mhm.
of like progress. So this is, I think, one of the hugest thing that they did, which is multi-head attention, but in latent space. They are calling it multi-late space. So that was number one. Number two that they did, which is again, it is not something that was really um, an innovation, but they took it a little bit further, is the idea of mixture of expert. And this idea came from Jeffrey Hinton's lab while he was working with, I believe, DeepMind and also Gemini model utilized this idea. But the thing that is interesting about DeepSeek that it went above and used more number of mixture of expert that is traditional and essentially in the field.
Okay.
But let me explain what is mixture of expert. So the idea of mixture of expert, and the reason that I want to make it clear is because some people make it, they confuse it with the multi-head attention. So in multi-head attention, the idea is these different people who are working together. So one of them works on your lashes and the other one works toward your nails. They work at the same time and they are both needed to achieve the final end goal. But with mixture of expert, each of the expert, only one of the expert is required to achieve the goal. And we have this router that decide which one. So the way that
Okay.
I suggest to think about it is imagine one expert is a doctor, the other one is a cook, the other one is a police. So there is no situation that you need a cook and you need a police at the same time to achieve the goal. Maybe there are some situations, but let's imagine there are not. So you have the router that chooses, okay, this is an emergency that you require to have help from a police. So that expert would jump in and help you and you achieve the end goal. So DeepSeek took it further, utilize more expert, and they have this very efficient router that chooses which experts should work on this specific problem.
So when we say it chooses a different are these different models? It's the same model architecture, but trained on different content or content that has different weights that weighted in a different way? Or I guess I'm trying to picture exactly what it is that's underneath things.
You've been in this field for so long, and I think you remember that we had this multitask predictive model. So we had one pipeline of the model and one output, for example, producing something, and we had this other pipeline that was a branch of the main model that would
Mhm.
produce a different pipeline. The way I see this architecture is the same thing. So we have parallel architecture that some layers of them share weights and some other layers do not share weights, but
Okay.
each of them would, when at the time of training, they train with the different pairs. So, for example, when the router decided that we need a policeman, we had this pair that made a sense for the policeman expert, and that's pipeline got trained. Again,
Okay.
I don't work for Google or DeepSeek or any of them. I just read a lot, and I hope that my analogies are correct enough.
Okay. Um, so what it sounds like DeepSeek has done is twofold. One is that they have taken the massive vector space and condensed it to a size that is easier to process or cheaper to process or faster to process or all of the above. And then done that with a huge number of experts
That is correct. But
so they can route more efficiently. So they're routing to exactly the right expert, and that expert is working on a scaled down set that it's tuned well for and can process quickly. Is that kind of the summary?
yes, exactly.
Okay.
But
Okay.
one more thing that I like to
Okay.
talk about is so a lot of major companies, what they spend a lot of money on is to generate this pairing of input and output. And we know there are job titles out there, for example, AI math trainer or AI literature trainer. And the idea is that you ask the AI a math problem, and then there is a real human expert who sits down and figures out what is the output and how that output could be improved.
Hmm.
So a huge expense associated with training the model is this idea of generating this pair for alignment and for fine-tuning this model to exactly create the right answer. But what DeepSeek has done, which significantly reduced the cost, is instead of having a human check the AI work, there are two DeepSeek working against each other. One of them
Hmm.
produces the answer, and the other one checks whether this answer makes sense. So they generated over 800,000 pairs that they utilized essentially to fine tune the model. I need to be clear that between that 800,000, if I quote the number correctly, they still had people go through them and figure out if they make sense, but the bulk of the work was done by AI itself. So, what is the part that made you question it?
So I feel like what my skepticism here is that, okay, so we basically have an unreliable system checking and tuning another unreliable system. And I could say, okay, if the number is 800,000 or whatever, let's say there's a 1% error rate. That still means that we have 8,000 of those answers that it trained on are now wrong. So it's trained on 8,000 hallucinations. I'm not comfortable with that. I still come from a world where, the point of the computer is to give you correct answers, not mostly correct answers.
Okay, I think the moment that we walked into the realm of generative AI, we lost that
I
making
I
sure that
grant
everything's right.
I grant that. But, I guess what it is that if I'm asking for whatever reason, if I'm asking it what 2 plus 2 is, I'm expecting it to say 4, not, uh, 1% of the time it's gonna say something else. There are things that and that's where I mean, that's been my discomfort with generative AI systems all along.
Okay, this takes a tangent, but I want to go down this tangent. What you are explaining, I, I, I hear that there are more discomfort when you have a system checking its own, like there are two AI checking each other.
Mhm.
But do you remember the GAN architecture? And we have a generative and we have an adversarial, and they would go against each other, and by time they would improve each other. So there was this
Okay,
huge
that's
architecture
fair.
before. I think you remember, but for the sake of audience, we have a generative model that would, for example, produce a picture of a person, and we had an adversarial model that would decide whether this person is real or generated. And just by training both of these models simultaneously, both of these models would get better. So the adversarial was really good and the generative was really good. This is, I think, the main idea that DeepSeek has done. And for a lot of the innovation that they did, I think they went back to 2016, 17, 18 papers, and they tried to mimic those ideas within what is happening right. But let's go back to what you mentioned about not feeling comfortable with these models because they are essentially a stochastic models. So even if for all of the pairs, we make sure that there is a human checking them, I still don't think that we are making them 100% error proof. But there is less chance simply because I have seen more number of right answers. And again, what DeepSeek did is they still had people checking some of the answers. So the reason that R1 is significantly better than V3 is because they still did some supervised fine tuning for alignment of it, but that is a subset of that is very smaller amount of data in comparison with major other companies. And also they utilize a subset of the data that AI created themselves. But there is this other aspect of having AI create and evaluate the data, which it makes it more generalizable, and it also make it very biased because humans we tend to have I would disagree if you say that's not the case, but we get stuck in like a certain style. So all of the responses would be the same way. And frankly, I don't see
No, no, no.
see a lot of people with a very diverse background working on this. And unless you don't have this, you are not able to bring all of this styles. Please go ahead.
So, so my reply to that was no. I'm not saying that humans aren't biased. We had a show a couple of episodes ago where that was exactly what we were talking about. Wasn't just that humans are biased, is that we're introducing that bias into our systems and then saying these systems are bias free. That's my concern on that front. And I don't want to get too much further into this because we could really talk for at least an hour about this. I know that. And I would love to have this conversation with you sometime about that bias. But I don't want to get too much further in the woods. So getting back to DeepSeek and what they've done and the models that we're now seeing. So we have two models that they currently have out there. One of the things that I think I've been hearing a lot about the R1 model is that it's what they're referring to as a reasoning model. And can you talk a little bit about what reasoning models are, or some people are calling them thinking models, which is a term I hate. But so what are these reasoning models and what is R1 bringing to the table?
I have so much issue with that term and with the
Huh,
idea that are able to reason because they are still autoregressive like token generative model. They are not able to take into consideration everything that is happening and then come up with a solution. But we thought that, okay, break this down and try to look into each of those pieces separately. So the way that this R1 or any other reasoning model are being trained is rather than having them to generate the output all at the same time, it's like we build this feedback loop and the output would be designed that, okay, you need to think about this 5 times, for example. And each time we take this output, we take the input and we put them together and feed them to the model again. And we do it again and we do it again. And there is this other innovation with DeepSeek that they use the reinforcement learning approach. So they were able to traverse a very wider area of approaches before coming up with a solution, which actually removes a lot of expenses again with building this model because the other way would have been like, okay, now we need supervised fine tuning.
mhm.
So, but I really don't want to talk about the reasoning model and thinking model because the moment that you get a little bit further from this community who are constantly reading literature and are really immersed in the technology, people would take this model as factual. And that's a very dangerous turn. So, as far as I'm concerned, these models are not thinking, these models are not intelligent, these models are not reasoning. They just learned how to make the flow of conversation make sense. And statistically, they have seen so many examples that the chance of what they say makes sense is good, but this is not 100%. So please don't take these models as factual. They don't
So
reason.
so let me so much there I want to reply to, mostly agreeing with. I'll agree with you. These are not factual. These are not fact systems. And I agree with you. We shouldn't think of them that way. That's part of why I don't like the name thinking, because they're not thinking. They're not applying human thought processes the way that we do. I liked reasoning more because that's more of a mathematical basis. But I'm willing to go with another name. I mean, I don't particularly like reasoning either. How would you describe, what simple term would you give for this sort of for this technique?
English is not my mother's tongue, so
That's
don't
okay.
question me on that.
No, that's good because it means you're bringing in a new way of thinking, a new set of terminology to the approach.
I don't know. I would think planner models or
Okay.
something in terms of they are able to break something down into a lot of tinier steps and execute each steps and then decide based on that step how they should proceed.
And this is similar to what was being called chain of thought, which is again a terrible terminology, but just the notion of breaking things down and then doing one, and then trying these patterns one after the other to see where our patterns end up at the end.
To be clear, I think from an architecture point of view or training perspective, the idea of chain of thought is now integrated within the training. So previously, the idea of chain of thought was to ask the model in the output to break this down and then make that chain. And we as user would input that to the model and say,
Mhm.
hey, okay, you did that, so how we should proceed. Now that's incorporated into the training. So the model does it on the go in the first turn. And interestingly, if now we do chain of thought with this model, they would go a little bit crazy because now they cannot do it twice.
And I think one of the things we always need to reground ourselves in when we're talking about these models is these are pattern systems, and that's really all the large language models are fundamentally are pattern systems, very very sophisticated pattern systems. And I still think it's kind of amazing in some ways that as pattern systems they can do what they can do, but they're
So
just pattern systems.
I cannot agree more with that.
Oh,
Absolutely.
thank you. That coming from you, that actually means a lot to me because I don't feel like I have a solid mathematical uh, fundamental understanding of what's going on here. So coming from someone who does, that means a lot to me.
Thank you. Honestly, that was the reason that I got into AI. Um, this is a segue, but when I started my PhDs, my advisor was working on a consensus building problem. And that was essentially the idea of how different agents would talk with each other. I started my PhD in 2016, which is the early days of like after AlexNet. And the idea of like doing AI was not really widespread. But for that specific type of problem, I had to get so deep into matrix manipulation and matrix algebra and generally linear algebra. So I was really good at it. The moment that I had the opportunity to learn AI, a lot of it was easy for me. Like all of those harder calculations, like, oh no, like I've done this before. Like they are really easy. So that was how I got into this. And like I felt like, okay, I belong because I already have done the hard parts of it. But thank you so much. I appreciate that.
No, and one of the things we always like talking about on the show is how people how people ended up where they are now and where they started and how that evolution has taken place. I am here from a completely different angle. So it's always interesting to me to see where people came from and how you got into it. Um,
So
but getting back to DeepSeek,
I really need to talk about this other aspect of this. So
okay?
you mentioned about the GPUs. And if we go back to the whole idea of deep learning, the reason that we have the modern deep learning is because of two things. We are owing it to Dr. Fei Li from Stanford for her work and building the ImageNet database. And we are owing it to CUDA um, from NVIDIA, which enabled us to essentially make communication and connection between the GPUs easy and available to whoever who wants to work on that. So that's where it started. And we were able to train this model with a lot of data with a required compute that were not large compute. They were just computes that work together very well and sync together very well. Now, coming back to DeepSeek, the GPUs that are available in mainland China are not the best GPUs that NVIDIA produces.
Mhm.
And these GPUs are limited for their computational power, but also from the inner bandwidth between different, essentially GPUs on the board. And rather than utilizing CUDA, to make these communication better between these different GPUs, what DeepSeek has done, they built their own inner pipe, essentially communication, to make the communication between these different compute better just for this specific architecture, which is very phenomenal in my opinion. If they ask me what is the one thing that they did that blew your mind, this is that one thing. I think this necessity and this limitation made them to innovate in a way that nobody expected. So all of those sanctions on GPUs that were like, okay, we are not going to let them have access to specific technologies now, or I would say they don't make any sense because they already passed that. But that is the reason that DeepSeek is so amazing. And that is also the reason that they are working with a much lower cost. I talk about cost in quotations because when we talk about OpenAI spending $100 million for training a model, we talk about all of the pre-training and all of the research and all of the money that company gave to the researchers, essentially all of the costs associated with it. But these things used $6 million only from the time that they started training to the time that this model was ready. So we are not including the cost of the research, essentially the compensation for the researcher, the cost of research prior to that. None of this is included in that 6 million.
So when we're not comparing apples and oranges, we're
Yes.
saying the 6 million was about the actual training, the running the training processes, not the developing this technology to have the GPUs communicate with each other better, not the research going into, not the understanding that's required to understand the mixture of experts, the headless attention systems. It's just the actual running and applying. So, okay, that's interesting. I wasn't aware of that.
That is important because something that bothered me then, like a few days after DeepSeek, it was like, oh my God, all of these scientists in the US, they don't know what they are doing. What they are doing, like they just like burn cash. And people in China, they were able to do it with a fraction of cost. This is not the reality of it. This is not a fair comparison. I gave it to DeepSeek. They did a very, very interesting job of doing these interconnections more efficient because I'm an electrical engineer, so that part really is interesting to me. But this is not all of it. I want to talk about one more thing about DeepSeek if I have time.
Sure.
So there was this controversy also on Reddit that, okay, OpenAI accused DeepSeek for utilizing their data.
Yes, I wanted to make sure we address this as well. So,
Thank you. I wasn't sure you are okay and on board with it.
oh yeah,
So the idea is, let me take a step backward. So we have this idea of distillation or master and a student, and we have a larger model and we utilize the pairs of input and output of that larger model to train this smaller model. And it's an accepted practice because it enables us to essentially get all of the information that this larger model has and condense it in a smaller model for a specific task. Also, we already trained that other model, so it makes sense to use those input and outputs to serve as pairs generation for this new model. OpenAI accused DeepSeek of utilizing this method. So they accused them that they inputted the GPT models and used the output, and this is how they build a supervised tuning. I respect OpenAI a lot. They are the reason that we have this large language model. I think they took a leap of chance. They trusted their research and they went with it and they could like break it. It actually made them. So huge respect and shout out to OpenAI. But at the same time, they utilized the information that was available on internet. It was not information that they created themselves and they used it. So frankly, I'm not really on board with them accusing another company using their data when there was never any compensation for people whose data was utilized in the first place.
So the argument, I guess your argument can kind of be summarized as OpenAI, who plagiarized the entire internet, is accusing DeepSeek of plagiarizing them. Is that,
Yes. And
crudely speaking, that's kind of the argument there?
and 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 even if we agree about this is what is happening for all of the history of science, there has never been a scientist being like, okay, like never a Newton came to Einstein and say, hey, like you're building it because like I built the Newtonian physics and now all of your relativity belongs to me because you have done it. Like Einstein wouldn't be Einstein if they wouldn't start from what Newton did and Newton from what who came before them. So we are always standing on the shoulder of giants who came
We are
before
standing on
us.
the shoulder of giants, but I think that's more in terms of research, in the sense that OpenAI published their research, the broadly how they did something. And from that, other people learn things. As you said, when it looks like DeepSeek went back and looked at the research and said, can we apply this research model to this problem? And the answer was yes. And that's one thing. Running things through OpenAI to see how they generated answers and using those answers in the patterns that DeepSeek made, I can certainly see why OpenAI would complain about this. On the other hand, I don't agree with OpenAI in this particular case, but I see why they did. And I then go and look at um, shortly after all of these allegations were coming out, Google changed how its thinking model worked so that it used to show those thinking tokens and it now prevented those thinking tokens from being exposed. And I'm guessing, and this is purely a guess on my part, it did that because it didn't want those reasoning tokens to be used as part of training for somebody else's model.
I can totally see that. I I'm more of a scientist than a business person. So I see it as even if this accusation is true and they actually did that, they did it and they generate a model that is cheaper to use, somewhat cheaper, and they expanded science a little bit further. So from a scientific perspective, I understand that. And I also understand your argument. Like this is business. OpenAI is making money off of it. So it makes sense for them to be like, okay, this is our data. If you wouldn't be doing this, we would have more customers. So you
Yeah.
I'm not in a position to say like what which one is right. I'm just saying that there are multiple aspects to this argument. Let's put it
Oh,
that
I
way.
definitely agree. I'm not saying I disagree with you completely either, to be absolutely clear. But I think it's important that we have this discussion, that we understand what it is that OpenAI has done, what it is that Google has done, and what it is that DeepSeek has done, or may have done, how they could have done these things. But
Absolutely.
but I think I think closing this loop, I guess, the important bit is that it's not that DeepSeek stole OpenAI's data and ran it themselves. They applied their own techniques. They applied research that they had done to make a significantly better and different product. And if along the way they used some of the training that OpenAI had done, that's a concern. But there was more to what they did. It's not that they just ripped off OpenAI completely and ran OpenAI's model on their servers. It's that they applied their own techniques to build their own system and may have used some of OpenAI stuff. And there's a
Absolutely.
difference there.
Absolutely.
And and it's important for us to understand and discuss what those differences are. Whatever side on it we take, we need to make sure we understand what we're talking about.
I cannot agree more. Absolutely. I want to talk about one more thing. I know this is the most controversial, so I need to talk about that.
Okay.
So there is this massacre uh, in China that happened, and DeepSeek does not release information about that issue. And that breaks my heart because I think scientists should stay away from politics. But given that these models are being built in different countries, I see how they are made worse, encouraged um, to stay away from certain topics. So think that these models, I don't think that these models specifically never saw those data, but I'm certain there are guardrails on top of it that forces it not to release any information.
And to be clear, what it sounds like, or the impression that I've gotten, is that the model itself has one representation. If you access the model, you're accessing it one way, and that a lot of these guardrails are actually applied in DeepSeek's chat system, the equivalent of ChatGPT. So to kind of use the analogy, GPT does some things and it may release some information that ChatGPT will block for whatever reason. When we looked at Gemini, Gemini had its safety settings that applied much the same. But even with the safety settings completely off, as you said, there are guardrails in place for
Absolutely.
certain topics and certain things. We can agree or disagree about where those guardrails are, what those guardrails should be. But the fact is that DeepSeek operating in the environment that they do have to impose certain guardrails,
Absolutely.
just like anybody operating in the US has to impose certain guardrails. Anybody that's operating in Germany has to impose certain guardrails. And these guardrails are all different. Agree or disagree, and I'm not saying I agree with that. That's
Absolutely. I
the
agree with you, but I think this is a call for more open source models because we need to have these models, and I call on all of the scientists out there. It it calls for us to make this compute more accessible in a way that we can tweak these models to do everything. And hopefully those who are working on them and all of those everything would fall on things that benefit all of the humanity, regardless of where they are based, what is this nationality, or the color of their skin, or their religion.
and that actually raises an interesting point that DeepSeek itself has released these as open models, haven't they?
Yes, they are
Now,
released as open model.
now they're not completely open source. We don't know all of the training material,
Correct.
but the models themselves are available for people to tweak the weights on. Is that correct?
Yes, that is correct.
Okay. So people who are using DeepSeek can use it on, I believe I've seen people talk about spinning up local DeepSeek instances or running them on Google Cloud or running them on AWS,
Yeah.
as well as using DeepSeek's own API.
Actually, one of the nice use cases, I think I need to say that because some people are like, this is a Chinese model, so they will steal our data. So if you're concerned with that, you can download OLAMA, and then you can get DeepSeek through OLAMA and turn off your internet and still utilize DeepSeek, and it works. So um, I think that's a really nice use case that now you can have them locally.
And I think that that's important. You and I am sure we're going to have more conversations in the future about local models, about training your own models. I look forward to discussing it with you.
I would love that.
And I look forward to discussing it with you because I know every time I've seen you talk about this, it has been an eye opener for me. So I'm looking forward to that. And I am sure we will have these conversations another time on Two Voice Devs.
Two-way steps.
Roya, thank you so much for joining me. Hope to have you on again another time.
Thank you so much for having me. It was a certain honor for me to be here.